Hello, everybody. All right, so today what we're going to do is we're going to go into our next section, which is called graphs of sine and cosine functions. Now, the nice part about this is with sine and cosine, you're going to be able to, if you learn sine, then you'll be able to do cosine because the properties and everything that we're going to be doing with sine and cosine are going to be absolutely the same. The only difference is the way the graphs look, because one of the graphs focuses at starting at the origin, while the other one of the graphs focuses at starting at 0, 1. And so as we go through this, your sine graph is what we're going to start with because it's going to be the easiest one. And then we're going to look at moving that graph literally 90 degrees and starting it with the cosine graph. So as we go through this, this is what we're going to be focusing on. We're going to look at the sine graph and understand how we actually are plotting it. And then we're going to look at the different variations of that. And then we're going into the cosine piece and doing the same thing. Now, what's nice about this is if you understand everything up here in sine, it's the exact same thing in cosine. The only difference is how the graph is going to look. It's just the way you're going to plot it. I mean, how you find periods and amplitudes and phase shifting and all this different stuff that we're going to get into here in a moment is exactly the same for both graphs. And that's why we always start with sine and cosine graphs when we're looking at actually graphing trig functions. We are going to graph the other six. I'm sorry, not the other six, the other four, because this is part of the six. We will graph the other four, but that's not until the next video. So this video is only focusing on sine and cosine. So let's jump into the sine graph. So if you think back on your unit circle has, all your degrees are radians in this case. And then it has, your XY coordinates of each point, like square root of 3 over 2, comma 1/2, 0, comma 1, things like that all the way through. So what we're going to do is we're going to now take a step back and we're going to take apart the unit circle. And as we take apart this unit circle, we're going to graph every single y value on that unit circle, focusing on each one of the degrees that we're going to be looking at, our radians. Okay. Your radians are going to be your x values, and your the y values on the unit circle are going to be the y values actually on the graph. So as we transpose these, that's what you need to keep in mind what we're doing here. So we are literally taking the x value. So every single radian on the unit circle from 0 to pi, this is our basis. This is what the parent graph is going to look like. So all of these are our x values. So the pi over 6, the pi over 3, the pi over 2, all of that, okay? And then we're going to turn around and then we're going to focus on, because we're dealing with sine here, we're going to focus on all those y values, which are these right here. And then we're just going to plot them with this being your x and this being a y. And then when you do that, you're going to get something that looks like this. So your sine value looks like that. It has two humps in it. And if you notice here at pi, right here, it's where your graph that takes us over here, it's reflecting, okay? So whatever is up here, it's going to mirror the same thing down here. You're going to have one max point and one min point. And then what happens is you're going to start at a specific point. You're going to go through all the points here, and then you're going to end back at that same y value. That is one full revolution. So if you took your circle and laid it down on an XY coordinate plane and plotted all your y points at the specific degree values or radian values, this is what you wind up getting. You wind up getting this blue graph right here. So this is your sine graph, is this piece right here. Okay. And then you notice your period is 2 pi. We call it a period because that's just how, when we're talking about trig functions, a period is the same thing as a revolution. But since we're not going in a circle on a sine graph, we're only looking at the y values. We call them periods. All right. So you have, when you do one full period, you've done one complete cycle. And I know everybody's snickering right now. you'll have one max point, you'll have one min point, and you will cross the x-axis somewhere halfway between, and that's when you're going to change. And then that's when you go from your min to max, max to min, depending on how we're actually graphing this. Okay, so we want to make sure that we're keeping all this in mind as we move forward. So here are some properties of your sine graph. Now, what's nice about this is the cosine is going to be exactly the same. The only difference for the cosine function, we'll talk about this later, is going to be this piece right here. But right now we're only focusing on the sine graph. And so this is your parent function tendencies. The domain is always going to be from negative infinity to positive infinity. So basically all the set of all real numbers. And it's just going to keep going. There's no gaps, there's no holes, there's no asymptotes, there's nothing. So it's continuous all the way through. However, let's talk about the range. So if you think about your unit circle, and I'm looking at my sine graph, so I'm looking at those y values on my unit circle, my y value starts at 0. And when I'm at 90 degrees or pi over 2, I'm up at 1. And if I keep going around my circle to pi, which is 180 degrees, I'm back at 0. And if I keep going around my unit circle to 3 pi over 2, which is 270, I wind up with -1. And I come back up to 2 pi, I'm back up to 0. So as you can see, I'm bouncing back and forth between 1 and -1. So my range is from -1 to 1. And again, since I'm continuous on the x-axis, I'm also going to be continuous on the y-axis. So there's no breaks, no holes, no asymptotes or anything. And then we talk about the period or the revolution, how long it takes you to go around the actual circle. Well, that's going to be 2 pi. So, and if you think about it, well, so basically what that's saying is it's going to take me 2 pi to go all the way around that circle one time. So your graph's pattern repeats in every interval of a length of 2 pi. So I've got from 0 to 2 pi, and then 2 pi to 4 pi, that's going to be another cycle. And then 4 pi to 6 pi, that's another cycle. 6 pi to 8 pi, that's another cycle, and so on and so on and so on. Okay. Now, here's what is different between the sine and cosine graphs. So, right as of right now, the domain, the range, and the period are the same for both sine and cosine. The sine graph is an odd function. So basically what that means is, since it's an odd function, that means if I was to substitute that negative x in, I get a negative sign back. And you can see, I'm going to go back a slide. You can see where that comes true, because if I'm plugging in all these negative negative numbers here, when I get to this piece right here, I actually have that symmetry. So if I was to move this whole graph right here, if I was to move this back a full, what is that, 180 degrees, what happens is that this now becomes my origin, which means that when I reflect across that origin, I wind up getting the same thing. So I can take my graph and I can take it and flip it upside down. And then when I flip it upside down, I get the same thing back. So that's why it's an odd function. So your sine graph is an odd function. Okay. So again, I talked about this a few seconds ago when we're talking about periods and cycles and everything. So your period will always stay the same from 0 to 2 pi until we get into later on. I'll show you how to figure all the other stuff out. But your parent function is from 0 to 2 pi. That's one period. That's one cycle. Now your period will always stay 2 pi. The cycle is what changes. So even though it says from here to here, I've gone 2 pi. That's the first cycle, or that's one cycle. When I go from here to here, this is also 2 pi. And then from here to here, this is also 2 pi. But we talk about it, this is showing 3 full cycles right here. We have 3 full cycles of 2 pi, which basically means I've gone from negative pi over to 2. I'm sorry, negative pi. Let's try this again. Negative 2 pi. Sorry about that, guys. All the way to 4 pi. So that's 6. That is 3 cycles of 2 pi each. There we go. Have my words now. I found my words. So that is what this is talking about. All right. So when we talk about graphing the sine function, so these are the steps in order that you're actually going to follow everything in. So the very first thing you're going to do, and if you need to pause the video as we go through, please do so, because this is kind of, you need to know how to do this, okay? The very first thing you need is you need to figure out what your amplitude and the period of the function is. So that's the very first thing you're going to do for both sine and cosine, is you're going to figure out, well, what's my amplitude and then what's my period. Once you do that, there are going to be 5 key points. So this is where it kind of gets a little different, because with your cosine, the difference is the x-intercepts. The cosine only has 2, whereas your sine actually has 3. So with your sine function, you're going to find 3 x-intercepts, a max point, and your minimum point. And so what's going to happen is once you do that, you're going to start with the value of x. So we need to figure out, well, where does your cycle actually begin? And then we're going to take that and we're going to take that period and we're going to divide it into 4 equal parts. So we're going to look at those quarter periods, so that way we can figure out the 5 points that you need. So you're going to have a starting value and an end value. And so that starting value, let's say, is 0, and the end value, say, is going to be 2 pi. So let me go back here so I'll show you what I'm talking about. If I'm looking at this graph here, and I'm trying to figure out my 5 key points, the first thing I got to look at is going to be my starting value. So where am I going to start? That's my first one. The second one is all right, where am I going to end? That's my next one. So that's 2 of the 5. And then what you're going to do is, once you find the 2 of the 5, the other x-intercept is literally halfway in between. So if this had been, 5 pi instead of 2 pi, then this value here would have been 2.5 pi. So literally, whatever you're starting with, 0 to 2 pi in this case, halfway between that is going to be pi. So that's 3 of your key points. And then what you're going to do is you're going to go from 0 to pi. Halfway between that is pi over 2. And then from pi to 2 pi, halfway between that is 3 pi over 2. So these are the 5 key points it's talking about. You have the 3 x-intercepts, so your start, your ending, and then halfway in between. And then you have your max point and your min point, which is halfway in between your 3 x-intercepts. So going back. Now, once you find your 5 points, the 3 x-intercepts, your max point, and your min point, then you're going to evaluate the function at each one of those points. So whatever your points are, so I'm going to go back again. So whatever your points are, so in this case it's 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to have my function sine of x. And when I plug in 0, sine of 0 is 0. So my first point would be 0, 0. My next point is pi over 2. So sine of pi over 2, sine of pi over 2, that's 90 degrees, which means that my y value at 90 degrees is 1. So that's my next point. And then at pi, I'm back at 0. And then at 3 pi over 2, I'm at -1. And then I'm back at 2 pi, which is 0. So those are my 5 points that I want to look at that I need those y values for. Okay, so we need to find the values of y for your 5 key points. Once you do that, then you're just going to plot the points and connect it. So you're going to connect your 5 key points, and it has to be a smooth curve. And then, unless it tells you different, you're going to graph one complete cycle. And then the 5th one here, and this is only if the directions say give me 2 cycles, give me 4 cycles, however many cycles it wants, then you just extend your graph. And so literally it's going to be the same thing, so except that you're just going to move everything over onto the next one. So you're just going to move everything basically 2 pi or 1 pi, depending on whatever that period is. Okay. All right. So let's talk about what period and amplitude is. So amplitude, that's the height. That's the height you are from the x-axis to your max value and your min value. The nice thing about it is whatever it is here, it's going to be the same distance over here. And so that's the amplitude. It wants to know how high or how far away is that max point and that min point from your x-axis. And it's always going to be the absolute value of whatever number sits in front of sine. So amplitude is always positive, and it's the number that sits in front of sine and cosine, because again, this applies to cosine as well. The period is going to be 2 pi over b. So your b value is whatever is in front of the x. So if you've got sine of 6x, that b down here is going to be a 6. If you've got 1/2 x, that 1/2 is going to be down here at b. But it's always 2 pi over that b value. And that's going to give you how far it is from start to finish. So your one period, your one cycle. Okay? That's what we're looking for. So this is always where you start. Once you figure that piece out, you're going to go halfway in between to find that next point, and then halfway in between from start to the halfway point to find your max value, and then halfway in between from the middle point to the end point to find the other x value. So that's how you find the x values for your sine value. So let's actually take a look at this, okay? So as I'm going through this, we're going to follow these steps. So determine the amplitude of y equals 3 sine x. And then we're going to graph y equals 3 sine x. But here's the kicker. We're going to graph it in these boundaries here. So if you have a graphing calculator, go ahead and turn it on and make sure you are in radian mode. That's the first thing you need to make sure. When you're in your graphing calculators, you need to be in radian mode. So for this problem here, we're going to graph from negative pi to 2 pi. So what we're going to do is we're going to determine what the amplitude and the period is for this right here. So I'm going to go ahead. I'm going to clear that. All right. So our amplitude is the number that sits in front of in this case, the sine. So the amplitude here is the absolute value of 3, which is simply going to be 3. And then my period, how far am I going in the case of this one? It's going to be 2 pi over your b. So if you notice right here that we have 3 sine of x, well, remember there's an imaginary 1 sitting here for this one. So I'm 2 pi over 1, which is simply 2 pi. So I've got my amplitude and I got my period, so that's a good thing. So now, here's what you're going to do. You're going to take this information and you're going to plug this into your calculator. So go ahead and turn on your handy dandy calculators. Ooh, is mine not going to come on this time? Hold on. Oops. Yeah, I don't need that no more. No. There you go. Let's see if mine will actually show up. There we go. There's that. There's that. And finish. I don't know why this is not showing up. Well, okay. So you have to follow along with me. So in your calculator, you're going to go to your window in your calculator. Well, first off, let's back up. Go to y equals. When you go to y equals, well, first thing you're going to do in your y equals button is you're going to put in 3 sine x. So make sure you're in radian mode. Once you're in radian mode, I want you to go to hit your y equals button, and in y1, I want you to put in 3 sine x. And then once you do that, hit your window button. Now, if you remember, it says that we're going to go from negative pi to 2 pi. So literally, this is what you're going to type in. You're going to go in your x min. You're going to come over here to your x min, and you hit your little negative button. And then you're going to go second in the little caret button. And that caret button, that's your pi. So your x min will be negative second caret. Second caret. And then you'll hit enter, and then you should get negative pi right there. In your max button, we're going to go to 2 pi. So you're literally going to type in 2 pi and hit your enter. And then here's your scale. So if you take a look at it, we're going to divide these into quarters. So if I took 2 pi and divide 2 pi by 4, I wind up with 1.57. So you're going to just literally going to take 2 pi in your calculator for under the x scale. You're going to go 2 pi divide by 4, and it's going to give you this 1.57, so on and so on. So that's how you look at your x max and x min. For your y min and y max, so we talked about right here your amplitude. Your amplitude is 3. So I always like to go one more and one less just to give myself enough room. So instead of -3 and 3, I went -4 and 4. And so that way you can see a little bit more on the graph, and it's not actually going to the top and to the bottom of your actual calculator. And that x scale, don't really care about. You can keep it at 1. That's fine. All right, so now that you have your window set up, here are your key points. So remember, I told you it's your period divided by 4. So since we know that our period is 2 pi, and we take that and divide it by 4, that gives me pi over 2. So we're starting at 0 because we're not adding or subtracting. We don't have any phase shifting yet, so we're starting at 0. And then I'm going to add pi over 2 to that, and I get this. And then that's our first x value after 0. Our second x value is the pi. Our next one is this as another pi over 2, which gives me 3 pi over 2. And then we're ending at 2 pi. Okay? So that's where, if you're taking a look at this, that is where these numbers are coming from. This is taking your period, whatever in this case for this specific problem, our period was 2 pi. We just take that 2 pi and divide that by 4, and that gives me pi over 2. And that's where these numbers here, here, and here are coming from. Now, once you have all these x values, we need to find the y values that go with those. And so literally, you're just going to create a table. All right. Now, unfortunately, if you go to the table portion into your calculator and type in those 5 points, you're going to wind up with decimals. It won't actually give you like the square root of 3 over 2 and things like that. That's going to come off your unit circle. So what you do is you come over here and say, okay, based off my unit circle, when my x is 0, so if I'm at 0 degrees, what is that y value? That y value is 0. Now, here's the difference with this. So this is where you have to remember, you have a little math that you're going to have to do. We have 3 sine of x. So when I go over here and I plug in, instead of x, I plug in 3 sine of pi over 2. Remember, this 3 is being multiplied to that. So I'm going to say 3 instead of sine of pi over 2. Well, what is sine of pi over 2? What is your y value at pi over 2? Well, that's a 1. So then I get 3 times 1, which is 3, and that's where that value here comes from. When I go to the pi pi, when I'm at pi, my sine value is 0. There's not much I can do with that piece there. So when I get to 3 pi over 2, the same thing's going to happen. I've got 3 times sine of 3 pi over 2. Well, what is sine of 3 pi over 2? So what is that y value at 3 pi over 2? That's negative 1. So 3 times negative 1 is negative 3. And that's where that value comes from. And then at 2 pi, my y value is 0. So these are my 5 key points. And you'll notice I've got these 3 are my x-intercepts. And then I've got a positive value and a negative value. Well, this positive value is my max. This negative value is my min. So now I'm going to take these and I'm going to plot them. And so when I plot them, I get this nice smooth little curve that's happening right here. All right. So, and that's all I need to do. So, but here's the thing though. I need to plot this from negative pi over 2 to 2 pi. Or I'm sorry, from negative pi to 2 pi. So that means, I need to back this up a little bit as well. Oh, I so wish this worked. I don't know why it doesn't work. So what happens is this is what you need to realize. If I'm going to go backwards, so if I'm going to come over here and I'm going to extend this piece out, so I'm going to have to hand draw this. We're going to extend this piece out, and this is what I know. I need from negative pi to 2 pi. So here's my 2 pi right here. All right. My negative pi, however, I need to go back a little bit. So when I go back to negative pi, I'm going to go to about right here. And this right here is going to be my negative pi. And I know halfway between negative pi and 0, that is going to be my negative pi over 2. Okay. So if you take a look at this, and remember I told you that this cycles all the way through. So if I'm going up here and I come down and I come up, that means if I was to continue on from 2 pi, I would go up. But if I'm looking over here and I'm going in this direction, that means I'm going to come down. And in this case, I'm going to come down to this negative 3 right here. And then I'm going to come over here. And so when I draw this to connect it to the actual first cycle, I get something that looks like this. So if you're looking at your calculator, your graph should look something like this right here. So it's going to start down here, come down, go up to the origin, come up, cross back down, and then come up. So you have this W looking thing on your calculator. Okay. So that is what your pi, negative pi to 2 pi should look like. All right. So now let's ramp this up a little bit. We're going to go from, instead of having just the amplitude, now we're going to have an amplitude and a period that we have to deal with. So we're going to determine the amplitude and period of this problem here. And then we're going to graph it in this basis right here. So again, the first thing that I'm going to want to do here is I need to find out what my period is and what my amplitude is. So start with the amplitude because that's the easiest. So it's the absolute value of 2, which is simply 2. And then your period. So in this case, remember the last one we only had a 1. This one we have a 1/2. So remember your period is 2 pi divided by 1/2, which is simply 4 pi. Remember, copy dot flip. And then, so now remember that x scale that we're going to have to deal with. So we take this answer here. So your x scale is going to be 4 pi divided by 4. So all your x values are going to go up by pi. So we're going to start with 0, and then go to pi, and then go to 2 pi, and 3 pi, and 4 pi, and 5. So those are the x values that we want to show up on your calculator. we know that we're going to be bounded between this piece right here. So we're going to be x minimum in your window is going to be 0, and your max is going to be 8 pi. So again, so let's start this over again. In your calculator, hit your y equals button. So you're going to clean out the last problem that we just did, and you're going to put in your new problem in your y1 button. So 2 sine 1/2 of x. Again, make sure you didn't change it out of radians to degrees. Please don't do that. Keep everything in radians. Once you have that typed in, hit your window. Your x minimum is going to be 0. Your x max is going to be 8. And then you're going to have a scale of pi. So this is what your window should look like. So again, here is my 0. Here is my 8 pi. And then here is my scale of pi. Our amplitude is 2, so we want to go -3 to +3. So we want to be bouncing back and forth between those because we want to give ourselves a little extra room. So this is what your window should look like. So now I'm going to show you a different way. So go ahead and hit your graph button. So now that you've got your graph button hit, what you're going to do is you should have something that looks like this that's popped up on your actual screen here. So we're actually going to use this way instead of going through and actually doing all the mathematical work for it. We're going to actually use our calculator to determine what these things are here. So this is what we know. We know that each one of these tick marks is worth a pi. We also know that we have these min and max values, that we start at 0 and end at 8 pi. So if we look here, you have 2 full cycles, and that makes sense because I'm going to go back a slide or 2. Because I have one period is 4 pi, but yet we're going to go from 0 to 8 pi. So I'm actually doing 2 cycles of a value of 4 pi is what I'm actually doing. So now, if I'm taking a look at this, I know that this value up here is 2. This y value is -2, then +2, and then -2. So that's what I'm bouncing back and forth between. And then if I'm counting, so here's 0, there's pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. So all that stuff is here. So all I need to do now is I take a look at this and I say, okay, well, since I've got all this stuff and I know all this stuff, I actually have all my 5 key points right here. So I actually don't have to do any of the math behind everything as long as I know how to read my graph. And so that's why it's important to make sure that your window is set up correctly so you can actually have a nice view of this and you can actually see what's going on here. Okay. So you can use your graph as another form of actually being able to find all the answers that you need. If you want to go through the whole mathematical process and go through and try to make your chart and your table and everything else, you're more than welcome to do that. But you have a calculator, use your calculator for this piece because it makes things a little bit easier. Just make sure you know how to read, what's coming, the information's coming off of your calculator. Make sure everything is at a pretty point. Make sure that, like, if I'm taking a look at this here, that max point needs to be at this crosshair at 2 because that's what my amplitude is. Because this has an amplitude of a 2 here, and this should be a -2 because, again, I'm 2 away, but I'm on the negative side. Okay? So this is just a different way of looking at it. But you're just taking the whole entire thing instead of having to go through and trying to actually mathematically figure out all these equations and everything else. You can just, let technology work for you instead of against you. All right. Again, so if you want to see what it looks like, you can go through the whole process here. And what I would do is then I come over here, I'd plot my points. I get something like that. But remember, when we're looking at this is a period of 4 pi. But I need to go all the way to 8 pi, so I need to make sure I just redo it again. Okay. All right. So now, those were kind of the easy pieces. So what we're going to look at now is called phase shifting. So phase shifting, just like in normal graphing and everything else, is just moving your graph left and right. That's called a phase shift. There's a little bit of work involved in it, so you just have to, when you're looking at this, make sure that everything is okay and that you're understanding what's going on or whatever else, and that you keep track of everything. So let's talk about what we're actually going to wind up doing. So if I'm looking at this, if I'm not starting at the origin, I have phase shifted somehow. And so if you take a look at this graph right here, you will notice that we actually have not started at our typical parent graph starting point, which is at 0, 0. We're actually starting at somewhere other than 0, 0. And so we're going to have to take this stuff and we're going to actually have to be able to figure everything out correctly in this. And how you do this is you take a look here and you have this starting point. So your starting point is going to be your C over your B. So again, make sure you're taking note of this. So your starting point is your X is equal to C over B. B is always the number that sits in front of the X. All right. Notice that it is a positive C here. So when you're doing this, let's see. If your C over B is greater than 0, we are going to be starting on the positive side of your X's. If it's less than 0, then we're going to be starting on the Y portion of it. So just pay attention to which way you're actually going to be doing this, okay? The easier way of looking at this is if you're not real sure of how this is actually going to be starting, we are going to look at it in this format here. So typically, we start like this. Normally, our normal period goes from 0 to 2 pi. And that's assuming that we don't have any shifting or anything else that we're actually doing here. So what we do from here is we say, okay, well, I need to get rid of this. I need to actually find my boundaries. So my boundary is the first thing I'm going to do is I'm going to add C to both sides. Okay. So now I'm looking at this. So now I want to get that X by itself. So I'm going to divide everything by that B here, here, and then here. And so what happens is I get my starting point, which is C over B. We're bounded with that X value, which is exactly what I want. And I'm going to end somewhere over here that looks like this. So that's really what we're doing when we're phase shifting. And if you want to just take the guesswork out of actually what you're doing, you can put it into this format and this will always give you your boundaries. And so it's just a little bit easier and cleaner for you to actually be able to see. Okay. So we're going to actually graph this. And this is with a phase shift that's in here. So you can go ahead and identify your A, B, and C if you want to. So that way things become a lot clearer for you. And so that way, as you're looking at this, you're not, freaking out going, I'm not really sure what I'm looking at. So we know that our A is for our amplitude. So we know our amplitude here is going to be our 3. So that's going to be the easy piece. And then we have to figure out the period, and then we have to figure out the phase shifting. And so once I do this piece, so before I go there, let me let's do this. So we already talked about amplitude. So now let's go to our, our period. So our period is whatever our B is, and so we know our B is 2. So our period is going to be pi. So our sine, typically, how it goes from 0 to 2 pi has now been cut in half. So now we're going to go from 0 to pi to make it one full circle around. So now the hard part is going to be figuring out this phase shift. So there's a couple of different ways you can go C divided by B. If that makes sense for you, then you're absolutely A-okay in doing that. So if you go with C divided by B, then you wind up with this. So C divided by B, well, we know that's 3 over 2. And so remember, when we're taking a look at this, I'm sorry, pi over 3 over 2. My bad. I can't read my own stuff, huh? There's that and that, so you can see a little bit easier. So then we're going to copy dot flip, and I wind up with pi over 3, because that's from my numerator, and then 1/2. Multiply that straight across, and I wind up with pi over 6. So this is our phase shift. We phase shift here. And so now we take what we normally would do, and instead of starting at 0, we're going to start at pi over 6. So now what we need to do is we need to come over here and take our phase shifting and go from pi over 6, and we're going to add a pi. That gives me 7 pi over 6. Because remember, our period is this. So we're going to start at pi over 6, and then we're going to end at 7 pi over 6. So this now becomes our full period that we're actually looking for. So that's what we're going to focus on here as we go forward through this piece here. All right. So now we have our amplitude, we have our period, we have our phase shift. So now you can plug everything into the calculator if you want to. Or you can do this by hand and find the 5 key points. So remember, you're going to take your period and divide that by 4. So in this case, it's pi over 4. So this is where, if you're not really good with fractions, this might be a pretty good place to be able to maybe look at your calculator and see. Remember, this piece here, this is your x scale. Pi over 4 would be your x scale. And so you're going to start with pi over 6. And then we go pi over 6 plus, our first key point here. So that gives me 5 pi over 12. And then we find the other points, and we know that we're going to end at 7 pi over 6. So as we go through this process, there's our first point. Here's our second point. There's our third point, our fourth point, and then our fifth point. Now, here's my recommendation. When you're putting this together, and if you have to ever graph these manually, don't reduce. Keep everything in terms of the same denominator. So in this case here, this pi over 6 right here actually isn't pi over 6. It's actually 2 pi over 12. And so that way, if you're trying to graph this on your x-axis and you're having to do this by hand, or if you're having to read when you get to the computer piece of it and you're having to line up what all these things look like, if you have everything with the same common denominator, it makes everything so much easier. Because when you're having to deal with the 3 and a 6 and a 12, and a 12, then it's kind of, it's no longer nice and fun to work with. But if you have everything in terms of the same denominator, you look at your 5 key points here. You have your 5 key points. Everything is with a 12. And so we have a 2, a 5, an 8, an 11, and a 14. You can work with that because you can take your, from 0 to pi, you can take that and you can divide it into 12 tick marks. And then you'll be able to plot it plot it the way you need to. So again, here's your 5 points. Find those y values. So you're going to go through and find those y values. So remember, your min and max point here when you're actually dealing with this. Remember, your amplitude is 3. So we have 3 and a negative 3. And then you have your 3 x-intercepts. And then you're just going to plot your points, and you should get something that looks like that. Now, in your calculator, when you're dealing with this, notice here your cycle no longer starts at 0, 0. That's what we were dealing with. So if you're actually taking a look at this and you're paying attention to this, your whole entire graph, there is your one cycle that looks like that. So if you notice, that is off, it's not starting at 0, 0, which is what the other graph started at. This has been phase shifted over. Okay. So that's what we're looking at when we talk about phase shifting. We're not talking about starting at 0, 0 anymore. So now let's talk about cosine. The beauty of everything that we just talked about in sine, 95% of it applies to cosine. So there's nothing new to learn. You're going to find the amplitude the same way. You're going to find your period the same way. And then you're going to find your phase shifting the same way. Everything is the same except for the way the graph looks like. And this piece right here. Because you have to remember, when you're on your unit circle, cosine is your x values, sine is your y values. Well, we just plotted all the y values. So now we're going to plot all the x values. And so given the same, again, so if you take a look here, we're given the same points as we had with our sine value. The same points that are right here. There's nothing different. The only difference is now we're looking at those cosine values here. All these cosine values, which means that we're no longer having that nice little, you start at the origin, you have a max point, cross the x-axis, midpoint, come back up. Now we're shifting literally 90 degrees. And when we do that, we get something that looks like this. So we get kind of a flighty little V or U, however you want to look at a U with, I don't know, like little hands or something. I don't know. So, but you get something that looks like this. And so remember, we had our sine graph. Our sine graph did this number here, like that. And so if you take a look at the sine graph, sorry guys, I teach math. I am not an artist. So our sine graph looks like that. And if you notice that the cosine graph looks virtually the same, there's hardly any difference. The only difference is the starting point. They have that same curve. They have that same flow. And so if you're taking a look and see how it's transposed, notice that they're virtually the same thing right here. And the same thing, they're just shifted, is all it is all the difference between sine and cosine. And so that's the beauty of sine and cosine. That's why we work with them so much in the beginning. And here's the other thing. So again, domain, range, and period, they're all the same. The only thing that's different in this case is an even function. And it's even because if I took a look at this right here, remember, even says I'm taking the I'm taking the y-axis and I'm cutting my graph in half. And so if I took it and I brought them together, I wind up lying, my left side is going to line up perfectly with my right side. And so you can't tell the difference between the two. And so if I'm looking at this right here, and this right here is my y-axis, if I took this point here and I did a reflection across it, I get that point, and then this point, and then that point. And so everything is the same. And so that is why that this piece here is an even function, because you have that symmetry right there at the y-axis. All right. So again, amplitude's the same. The absolute value of A. There's no difference in that. Your period is going to be the exact same way of finding it, 2 pi over b. Your phase shifting, exactly the same way. You're going to do exactly the same thing that you did in the sine graphs. You're going to do the exact same thing here with your cosine. And then when you plot the points, it's going to look something like this instead. It's not going to have this little flow here. It's going to have that V looking flow instead. So that's what you're looking for when you're looking at a cosine graph, is that V format. So now, determine the amplitude, period, and phase shift of this whole piece right here, of 3/2 cosine of 2x plus pi. So I'm not looking for anything else except amplitude, period, and phase shifting. So as I'm going through this, I want to identify my A, B, and C. So I don't remember if I did that. Did I do that already? Yeah. So my A is the 3/2. My B is going to be the 2. And then my C, notice how it says negative C? So actually my C in this case is going to be a negative pi. So when I come over here and I put everything together, my amplitude is 3/2. My period is 2 pi divided by 2. And then my phase shifting is going to be negative pi over 2. So that basically means if I'm looking at a graph here, instead of starting on this side at pi over 2, I'm going to start over here at negative pi over 2. And I've got something that's going to kind of do that number there. And I'm going to end at pi away. So if I go a full pi over here, I wind up at pi over 2. So I'm going to start at negative pi over 2 and end at pi over 2. So that's all this is saying. So it's the same stuff that we've been doing with the sine. It follows suit when it comes over here to cosine. So that's a really nice thing to have. And there's, it's not anything new that you have to learn. So same process, same setup, same everything. So let's talk about vertical shifts. So we talked about A, B, and C. So now we're bringing in a D. D is anything that sits over here on the outside. So what happens is when you have a vertical shift, it's no longer the x-axis. So right now, everything that we've been sitting on the x-axis. If you have a number that sits out here, oops, I just did something wrong. If you have a number that sits out over here, for both sine and cosine, so that D value, so this here and this here, this becomes your new x-axis. And that's what you need to get in the thinking of the concept of. That your x-axis is no longer what you're working off of. You're actually going to be working off of that had it been a 2. Your new quote-unquote x-axis is going to be at 2. And then you're going to follow suit with everything else. So nothing will change except that you have to have the mentality of the C. Instead of sitting on the x-axis, you're going to be sitting on whatever you're adding or subtracting to this whole entire thing. So find all the key components to this graph and then graph one period on your calculator. So as we go through this, we're going to be doing the same things that we've been doing beforehand. So we are going to find your amplitude, your period, and your phase shifting. All of that's going to be the same. So if you take a look at here, notice that we're not adding or subtracting anything to that x. So we don't have any phase shifting at all whatsoever. The new piece is this piece right here, that 1. So what happens is we have a vertical shift and we're going to move everything 1 up. So when you plug everything into your calculator, you have an amplitude at 2. But because you're not sitting on the x-axis, instead of going from 3 to negative 3, this is where you're no longer balanced. So we know that we're going to shift everything 1 unit up. So if I go up 1 unit this way, I go to 3. And when I go this way, I'm going to 1. Because you still have to have that balance when you're dealing with these graphs. Because you know that sitting right here, you're going to be sitting. Oh, where are we sitting at? We are sitting at a 1. So we're going to be going, if this is our 1 right here, I lied to you, it's not 1. There we go. If I'm looking at this 1 right here, if I add 2 to that, I get a 3. And if I subtract 2 to that, I get that negative 1. I wrote a 1. It's supposed to be a negative 1. And so that our new x-axis, instead of being at the x value, is actually going to be at the 1. And so when you actually go through and graph this, now, what you need to take a look at is that your symmetry is no longer at the x-axis. Your symmetry actually is now right here. That is that one. That's that phase shifting piece. And so if you take a look at it from here to here, that value is a 2. And then from here to here, that value is a 2. And then again, from here to here, that value is a 2. And so that's what it's talking about when you're not phase shifting, when you're doing a vertical shift. You're just taking it and you're moving it up and down, but you're literally creating a new axis that you're going to be building everything off of. So just keep that in mind when you're actually going through these problems. Okay? So let's take a look about what does this look like in your homework. So one of your homework questions is going to look something like this. Find the amplitude and the period for 1/4 cosine 9x. So take a few moments, pause the video, and let's see how you did here. And do it now. All right, welcome back. So your amplitude is the absolute value of 1/4, which is just simply 1/4. Your period, that is 2 pi over your b, in this case is 9. So your period is 2 pi over 9. There's nothing else to do. You can't reduce anything. That's all it's asking for. So that's what you should have come up with. Okay? Determine whether the following statement is true or false. The graph of cosine of 4x plus pi over 2 has a phase shift of -8. I'm sorry, negative pi over 8. So we're phase shifting here. So again, when we phase shift, we're looking at C over B. So take a few moments and see if you can answer this question. Go. All right. So let's identify what we've got here. Our C is pi over 2. Our B, what is our B? Our B is 4. Now, did I make a mistake? Did anybody catch it? You should have, because it's not pi over 2, it's negative pi over 2, because remember, it's bx minus c. So that's the key that you need to remember. And so since this is a positive pi over 2, this has to be a negative pi over 2. Okay? So then we've got negative pi over 2 all over 4. Copy dot flip. And when I wind up with that, I get negative pi over 8. So your answer should have been true. All right. Determine whether the statement is true or false. The maximum value of the function of y equals -3 cosine x of 2, plus 2, is 5. True or false? So take a few moments and see if you can figure this piece out. And go. All right. So if I'm taking a look here, my amplitude is the absolute value of -3, which is just 3. Now I'm talking about a maximum value, so I don't need to worry about phase shifting or periods or anything else like that. So what I need to look at now is if I was on the x-axis. So if I was traditionally here, my max value would be 3 and my min value would be -3. But if you notice, I'm no longer on the x-axis. I'm actually at +2. So if I'm taking a look at this piece here, I'm coming over here and say, okay, this is where I'm normally at, but really this is my new spot here. My new spot here, my new quote-unquote x-axis, is a 2. And so if I take my amplitude of 3, my max value will be at 5, and my min value will be at -1. So it's telling me that my maximum value is at 5. That is a true statement. All right. So we're going to determine the amplitude and period of the following, and then we're going to graph it. So this one's going to be kind of a little interesting. So this is actually one of your first graphing ones that you're actually going to have to do here. So we're going to talk a little bit about this piece. So the first thing we need to do is we need to find our period, and we need to find the amplitude. So amplitude, again, absolute value of that 10. That's just a 10. Your period is 2 pi over 1/2. So is 4 pi. So that's going to be the first part. So let's talk about the graphing piece. So on the graphing piece, what's going to happen is you're going to get something that looks like this. You have this editing tool that pops up here at the bottom. So if you take a look at here, you've got these two, you got the little arrow button, then you have these two graphs that are sitting right here. So if you take a look at this first one, that's your sine graph. Your second one is your cosine graph. You don't need to worry about anything else over here, just these two. So you'll click on the sine graph, right? Because that's what we're looking at. Yeah. You'll click on the sine graph here, and then what happens is this pops up. And so what it's done is just plotted your parent function. So this is what the parent looks like. What you have to do is come in here and change that information. So we know that our amplitude was a 10 and our period was 4 pi. So you'll put that in there. If there's any vertical shifting, you'll put that here. If there's any phase shifting, you'll put that here. And then once you've done that, it'll plot this and it'll change it. And it'll do to exactly what you need it to do. So you're going to wind up with something that looks like this. So once you have everything in there, it stays yellow until you click the OK button, and then it'll turn blue, and then that'll be what you're going to answer. Okay. So that's how you graph it. So hopefully that's not going to be too difficult for you. Those are the questions that you're going to wind up seeing in your actual homework. So please, as you're going through them, if you have any questions, make sure you're hitting that Ask Your Instructor button and then shooting me an email so that I know to check my PJC email. If you have questions, please ask. Send me a remind, send me an email, send me something. That way we can talk about it. All right. So now that we're done, hopefully there's not that many more questions. You can start your homework for 5.5, graphs of sines and cosine functions. I hope everybody has a great day. I hope I answered a lot of your questions, and I will see you when I see you. Have a good day. TTFN. Ta-ta for now.